Hello all, I'm Raul and I'm going to present this paper titled Retrieval Guide Unsupervised Multi-Domain Image-to-Image Translation. In this work, we propose to use an image retrieval system to boost the performance of an unsupervised image-to-image translation system. The goal of the image-to-image translation system is to generate images similar to an input image but in another domain, that is, with different attributes. It is unsupervised because it does not need paired data between domains to be trained. In our experiments, we use a dataset of face images with annotated attributes, where the domains are defined by the hair color, the gender, and the age of the person. The presented idea can be applied to other image-to-image translation models, but we build over the GMM unit model. I won't get into technical details about this model in this video, but you need to know that GMM unit learns a content feature extractor and an attribute feature extractor. Content features encode the visual appearance of the faces not related to the domain, while attribute features encode the visual information related with the domain. Our hypothesis is that a retrieval system able to find real images similar in content to the input images but in the target domain can help an image-to-image translation model to generate more realistic images. In this specific example, the retrieval system finds images similar to the input one but with black hair, and those images are used as additional information to train the image transformation system. This is the procedure we follow. First, we train an image-to-image system, in this case a default GMM unit model, which learns to extract content and attribute features. Second, we train an image retrieval system able to find similar images given content and attribute features. Finally, we fine-tune the image-to-image system with the retrieval guidance. Since the first step is a default image-to-image model training, I'll go directly to explain the second step, the image retrieval system training. The image retrieval model itself is quite simple. It has as inputs the concatenation of content and attribute features, and it consists of a set of fully connected layers until an embedded sample representation is computed. It is trained with a triplet ranking loss to generate similar representations for images with similar content and attributes. The proposed triplets mining strategy is crucial to achieve a good image retrieval performance. The anchor of a triplet is the content of a random image and a given target domain. The positive is the content and the attributes extracted from the anchor image translated to the target domain. We use different types of negatives. Easy negatives are formed by the extract content and attributes of a random image, so they are different in both content and attributes to the anchor. Medium negatives are the result of translating a random image to the target domain, so they have the same attributes as the anchor but different content. Hard negatives are obtained by translating the anchor image to a random domain, so they are similar in content to the anchor but different in attributes. And hardest negatives are obtained by translating the anchor image to its own domain, so as hard negatives they are similar in content to the anchor but different in attributes. Now we see some image retrieval results similar to the query images but with different attributes. Also, a quantitative evaluation of the retrieval system, which shows that the triplets mining strategy is crucial to retrieve images similar in both content and attributes to the query. Once we have trained the image retrieval system, we can exploit it to fine-tune the image-to-image translation model using the retrieval guidance. During training for a given input image, we retrieve the most similar images in the target domain. We extract content features from them and we merge them with the input image features at the generator's input. We expect that the generator will benefit from that additional information to generate more realistic images. Importantly, during this training, the content and attribute feature extractors are frozen, because if we update them, the retrieval system would struggle. Results show that the proposed system can generate realistic images in different domains, and image quality metrics show that the proposed retrieval guidance boosts the baseline GMM unit image-to-image model performance. The main contribution is that we are the first ones using a retrieval system to guide an image translation system, and note that the retrieval guidance can benefit from additional and annotated data. Bye bye.